All right, we're back here in chapter 1 again, looking at some trigonometric functions. So we're going to define the trigonometric functions, and there's 6 of them, and they're listed there across the top. The sine, cosine, tangent, cosecant, secant, and cotangent. And we're going to define them essentially in terms of a right triangle right now. And that will allow us to do a lot of the work. You'll find yourself kind of bouncing back and forth between right triangle trigonometry and circular trigonometry. And just because of how things are presented, you definitely want the flow both ways. At least that's been my experience. And so we'll define these trigonometric functions below. But let me draw a picture really quick. I'm going to put a coordinate axis in here. And I'm just going to choose an arbitrary point. I'm going to choose a point right here that's on this line called x comma y. And it says let theta, an element of the real numbers, define an angle in standard position. Well, if it's an element of the real number, it says in radians, but I guess that doesn't matter for us really. But there's theta. So theta is that angle right there. Choose any point x, y on the terminal side. So I could have chosen that point. Let me come in here with the red. I could have chosen this point, or this point. It wouldn't matter. All of those would give me the exact same relationships. And here's how you know why. So the trig is going to be relationship oriented. And it might have been in the appendices sections that you've looked at already, but certainly should have been part of your work in earlier classes. If I start dropping lines straight down with all of these, what you have are 1, 2, 3, 4 sets of similar triangles. If they're similar triangles, then the ratio of the sides have to be equal to one another. That was one of the reasons why we had you do problems where we said, hey, this is 6 and this is 8. If this is a similar triangle, right, if those are the same angles, and this is, let's say, 10, what's this? And we would be able to figure it out. And so how would we figure it out? We would say 6 is to 8 as what we want to find is to 10, and we would just work from there. Um, and in this case, it would be a decimal, but we would be able to find it. We would have just said, hey, that's 60 is equal to 8x, x is equal to 68. 8 goes into 60 7 times, and 4 8, so 7.5 coming through there. So 7.5 would be that height of that side. My point in sharing that all with you is that's why we're able to choose any point, is because as we choose any point, it doesn't matter because what the trig functions are going to be related to is a ratio of sides. So let me come in here and erase all these red marks that I put in here so that we can focus just on the blue. And erase that line there too while I'm here. So let me come back in blue, represent this angle. So here's what you know. If we drop a line straight down, right, if I just dropped a straight line, you know that the distance across the bottom is x and the height distance is y. Now I'm trying to drop it straight down. It doesn't look so great, but it's forming a right triangle. So they call obviously this is x, this is y. They'll call this length from the center out to the point that you chose r. And as we go to make our definitions, they're here. Now, it's not surprising. I'm actually just going to jump right down here. This should not shock you at all when I'm boxing here. The r is equal to the square root of x squared plus y squared. That's just the Pythagorean theorem, right? Solved for r. And so what sine is, sine of theta, it's written there, but let me just do it in succession, is I'm going to mess up already, that's funny, is y over r. So there's a few things that you want to get out of just that statement right there. The first is that sine is, remember this is theta right here, let me put it in green. This is theta right here. And so sine is opposite over hypotenuse. when you're looking at the right triangle. Sine also corresponds to the y height. That's the other association you want to make. Sine corresponds to y. The next main one is its cofunction, and we'll talk more about that terminology, cofunction, as time goes on. Cosine theta. Cosine theta is defined to be x over r. So notice that that's adjacent side over hypotenuse. Let me write that a little bit better. I started to write the wrong word in there. It's looking really messy. Adjacent over hypotenuse. And so the side that's adjacent to the angle is x, adjacent over hypotenuse. But another thing is that cosine corresponds to x. Tangent of theta, they're saying is y over x. Now, tangent theta is like slope, and if you remember how you found slope, it was y's over x's. That's a good way for you to remember that. They're also going to make a qualification that x can't be 0, and that's for obvious reasons. All of these can't be 0 here because you can't divide by 0. They'll be undefined at those angles that cause it to be 0 on the bottom. But we'll handle that. So those are your three main ones: cosine, sine, and tangent. So I want you to notice that the tangent is opposite over adjacent, right? Y over x, opposite over adjacent. So this SOHCAHTOA that's down here is an easy way for you to remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now, you're wondering, how do you find the other ones? Well, cosecant of theta is the flip of sine. It's directly related to sine, and so it's going to be r over y. And secant is related to cosine, so you're going to flip the cosine. That might be the hardest thing to remember, is that cosecant flips sine and secant flips cosine, but it is true. And so that is r over x is displayed here, and obviously then cotangent would just flip the tangent, and so you'd have x over y. You're going to be very, very, very familiar with these functions because you're going to go through the homework, and they're going to be the standard of everything that we're going to do in this class. So the purpose of this class is so you can walk into future classes and never have trig taught to you again. You just know it, because that's the way they're going to take on it. That's their take on it. They're not going to review it. So let's see what we have here. The terminal side of an angle theta in standard position passes through the point 8, -6. Find the values of the 6 trigonometric functions. Okay, we can do that. So let me draw a large set of coordinate axes right there. And we got to go 8, 6. Let me go 1, 2, 3, 4, 5, 6, 7, 8. So we're 8 out and we're 6 down. And at the intersection of those is the point 8, -6. So notice it's in the fourth quadrant. We need to draw that angle, right? Because if you read the question carefully, it says the terminal side of an angle theta in standard position passes through the point 8, -6. So where's my angle? Actually, it could be two things. It could be this angle right here. Actually, an infinite number of things. It could have gone around once and ended up here. It could have gone backwards and ended up there. There's lots of angles that have the exact same terminal side, and I'll qualify lots by an infinite, and we'll see that as time goes on. Well, if we're going to answer this, then we need to know some things. We need to know what x is. No problem, they gave that to us. We need to know what y is. No problem, they gave that to us. And the other variables are. Problem, we don't know it. But we do know this is 8, and that y is, and I think it's very wise to have the negative sign on it. So 8 and -6. So what's r? You know what r is. It's the square root of 8 squared plus -6 squared. R is the square root of 64 plus 36. R is the square root of 100. R is 10. Awesome. So what's the sine of theta? Well, we're going to remember sine corresponds to y. or we're going to remember sine is opposite over hypotenuse. Here's theta. You want to picture theta as the angle inside here. That's the easiest way. So picture your right triangle, and it's this angle that we want. Here's your right triangle, and we have a negative 6 over 10. And they'll want you to reduce that to negative 3/5. Cosine theta, no problem. X over 10. And we get 4/5 out of that. So notice that the sine is positive. Sine is negative and the cosine is positive. We got tangent of theta. What is that supposed to be? Tangent's opposite over adjacent, or tangent is y's over x's. So opposite over adjacent, so negative 3/4. Then we've got cosecant theta. That's the flip of sine. Easy now, negative 5/3. So notice cosecant is bigger than sine. And then we have secant theta. What's that? That's the flip of cosine. That's 5/4. And then we have cotangent theta. No question who to flip there. Negative 4/3. And so you'll want to just early on associate sine and cosecant as flips of one another. All right. So they have some wonderful questions. Find the 6 trigonometric values for of an angle theta in standard position if the terminal side theta is defined by 3x minus 2y equals 0 for x less than or equal to 0. Okay, so that last piece is super critical. For what x is less than or equal to 0. So we got to get this line. Now, let's just find the line in general. If you wanted to find the line 3x minus 2y equals 0, well, one point that's on there is the origin, 0, 0. So we absolutely know 0, 0 is on there. Now, what else do they want? They want to have our x's less than or equal to 0. So we plugged in 0 for x, and we'll get 0 out for y. Let's plug in x being negative 2. Now, I'm picking negative 2 for a couple of reasons. Number one, because it meets the criteria that x is less than or equal to 0. And number two, because it's going to have me get a whole number out. How do I know? Because the last thing I'm going to do to solve for y is divide by 2, or in this case, negative 2. So therefore, I want to pick an even number. So if you're okay, I'm going to manipulate this before I plug in. So I'm just moving the 2y over. I'm going to plug in, and I'll use red at this point as I plug in. I'm going to plug in the negative 2, and we're going to figure out what y is. And we'll get negative 6 is equal to 2y, or y is equal to negative 3. So negative 2, negative 3 is a point on the graph. Okay, when I plug negative 2 in for x, I get negative 3 out for y. Okay, so let's go plot that. Negative 2, negative 3, right here. And this is the terminal side of that. Now remember, I can use any point I want, so I might as well use this one. I might as well use the negative 2, negative 3 value in there. Ooh, negative 2. Negative 3 value in there. Okay, and then we go forth and do. So I'm going to use my eraser here. Actually, let me just draw this triangle a little bit off to the side. So I'm going to take this triangle and I'm going to draw it right over here. So this is supposed to represent that triangle. This is negative 2, this is negative 3. Because when I went left 2, I had to go down 3 in order to get another point on there. You can check your work too. Negative 6 plus 6, yeah, that's going to be 0. So that's our work, just to find the x and the y that are on the line. And so it's really good work and all of here, good thinking aspects. And that's what we want out of this course as well, for you to be a thinker, right? To take a situation and work through it. So what we're missing though is, sorry, I forgot I still had the eraser. What we're missing though is the r. So we got to solve for r. R is the square root of negative 2 squared plus negative 3 squared. So r is equal to the square root of 4 plus 9, which is equal to root 13. That's going to happen a lot, to have a square root in there. So now we're going to go and figure out our sine, right? Because they want the 6 trigonometric values of them. Sine is opposite, or the y value, over the r value. Now, you cannot leave it like this. You must rationalize the denominator by multiplying top and bottom by root 13. I know you've done that a lot in previous classes, so I'll just drop it in there. Cosine theta is adjacent over hypotenuse. And so we're going to have negative 2 root 13 over 13. So notice they're both negative. Tangent theta. What's tangent theta going to be? It's going to be opposite over adjacent, or y over x. No, they're both negative. You cannot leave two negatives. You must express it as positive, and we get a positive 3/2 out of that. So the rest is easy because they're just flips. Now, who's the flip of sine? Cosecant. Now, don't flip the rationalized version. That's your answer for sine. Flip that initial one, and you'll be done. Otherwise, you'll have to rationalize again to get this. Negative root 13 over 3. Secant theta, the flip of cosine, is going to be root 13 over 2, but it's going to be negative. Sneak that negative in there. And we've already done tangent. So cotangent of theta is going to be 2/3. So pretty nice to go through there and do that. I want to just point something out. What if you were to solve this equation for y? You would have had something like 3x is equal to 2y. Divide by 2, divide by 2. And you would have something that looks like this. 3/2 x is equal to y. Now, what's the slope of this terminal side line? Well, it's 3/2. Notice that the tangent is also 3/2. Tangent is really closely connected with slope. And so it's going to be used as a pretty major calculus concept in there. So we're going to do the same problem, graph 2/3 x, and use the graph to determine what tangent really means. I think I just explained it, but let's grab 2/3 x. That means if x is 0, y is 0. If x is 3, then y is 2. So 1, 2, 3, 1, 2. And what we want you to find is the tangent of angle theta. The tangent of angle theta, we don't even need to find our r. It is y over x. It's 2/3, and we want you to see that tangent is really related to the slope of the terminal side line. Now, quadrantal angles are angles that are formed when the terminal side lies on one of the axes. And so this looks very cumbersome in here. This means theta, the angle, is an element of. So theta is an element of this set. So what is this set? This set is 0 plus 2k pi. So if you think about 2k pi, you're going to just keep ending up on this side. Remember, we did that 3.1. 2 pi around brings you right back here. So here's 0 degrees, plus 2 pi brings you right back, plus 4 pi brings you right back. Right? So all those are just basically saying if you're ending up on any of these straight out sides, we call those quadrantal angles. So this would be a quadrantal angle of 0, 2 pi. In degrees, 360, 0 degrees, 720, 4 pi. All those would end up right there. That's one. Let me go to green. This is also a quadrantal angle if you were to end up here. What's that? This is the pi over 2, or 90 degrees. Right? Or what else could it be? Well, it could be 2 pi plus pi over 2. So what would that be? So if you had 2 pi, that would be plus pi over 2, that would be 5 pi over 2 would be there. Or 90 degrees plus 360, right? And if we look at 360 plus 90, we get 450 degrees. All those would end up right there. And so, and then similarly, this would be the pi one, and this would be 3 pi over 2, right? Or 180 degrees and 270 degrees. Okay. And so we want to know the sine, cosines, and tangents of those. I cannot stress this enough. You have to have these memorized. If you're coming to the test and saying, well, our test, he says I can use a calculator. Well, I'm only doing that because I can't enforce really a no calculator policy when you're not sitting in a classroom with me. I've caught people using calculators in Math 335 in the class and giving them zeros on the test. So I'm not making that stipulation because I can't police it. However, if you walk into the next class and you don't know what the sine, cosine, and tangent are of 0 degrees, 30 degrees, 60 degrees, 90 degrees, 180, 270, you might not pass that class. So take the time to memorize is the message. It's not necessarily hard. So what are the quadrantal angles? Well, 0 degrees would be right on that line. 90 degrees. Let me move this up so it's not so crazy. 180 degrees, 270 degrees, and 360 degrees. What are those in radians from 3.1? 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. And what's the sine? So I think everything can be done visually. Since this is in blue, I'm going to go in red. Here is 0 degrees. Now, here's one of the reasons why I wanted you to know some letter associations. Do you remember what sine corresponded to? Sine theta corresponds to y. It's y over r, right? Talk to me about the y height here. You are up nothing. It's 0 degrees. Or sorry, its sine is 0. Because the y is 0. How about the cosine? Now, I want you to picture this because it could have any radius as having radius 1. Well, actually, let's not. Let's picture it as having r. I shouldn't say that because then you think something special is going on. I don't want that to seem special. So I'm going to come down here and just write my cosine theta. We know cosine theta is x over r. Well, x and r have to be the exact same thing when it's directly on the line. But remember what r is. R was the distance out. We don't have a triangle. So x and r are the same thing. And so therefore we are going to have a 1 here. Tangent. Tangent is y over x. So think about that. That's 0 as your y divided by anything. Now x is this straight out distance here, r. So we're going to get 0 out of that. And then just flip. Don't do anything else. I'm only going to fill in the first 3 and then we'll flip them all. That's the 0 degree one. So let me take my eraser and we'll go move somewhere else. Okay, where are we going to move? We're going to move to 90 degrees. Here we are at 90 degrees. Okay, sine corresponds to y. Well, let's make this out a distance r. Then sine is going to be r, its y height, divided by that same r length. It's going to be 1. So notice that the quadrantal angles, we get some extremes going on. Cosine, it corresponds to x. We are no distance x out. And tangent is y. Okay, the y height is r. So when we go to do tangent, it's the y height r divided by the x is 0. Well, what's r divided by 0? Undefined. And we get an undefined answer there. Pi. It's the first time we got an undefined. We'll get it a lot. because of these relationships and different angles and things. But we're going to handle that just fine. 180 degrees, or pi. So notice that this point right here is negative r comma 0. So what's sine? Well, sine corresponds to y, and y is 0. What's cosine? Cosine is negative r divided by r, so negative 1. Or we're going in the negative x direction. There's ways to talk about this. And what's tangent? 0 divided by negative 1. Tangent theta is y over x. Remember, who's y? Sine theta. And who's x? Cosine theta. So you can just do 0 divided by negative 1 for 0. 270 degrees. Right? And I'm trying to be really patient showing you this stuff. You can pause the video. I just don't want to go super quick because this is our foundation. 270, what point is this? 0 comma negative r. So what's your sign? Your sign's negative 1. Notice we're going negative y direction. Okay. Cosine. Well, cosine is the x. We're going 0 in the x direction. Tangent is sine divided by cosine. Negative 1 divided by 0, undefined. Okay, that doesn't look so great, so I'll go in here and try to erase it and rewrite it. I don't want to use a 0 with the line through it because that's not super appropriate. I just want to use the words undefined. And then last would be 360 degrees, but that looks just like 0 degrees, so we're going to get the same answers. It's that one duplicated. So I stopped there. Now, cotangent is what they have listed next. A little bit strange. Usually they do cosecant, secant, cotangent. Cotangent is the flip of tangent. That's going to be undefined if you flip 0. If you flip, secant's going to flip who? It's going to flip cosine, and the flip of 1 is 1. Cosecant's going to flip sine. It's going to be undefined. At 90 degrees, cotangent, if you flip undefined, you actually get 0. And you can get a justification about that right up top. If you flip 0, you get undefined. And if you flip 1, you get 1. Again, cotangent's going to flip 0, so undefined. Secant's going to flip cosine. Flip of negative 1 is still negative 1. And cosecant is going to flip sine, so this is going to be undefined. And cotangent theta, flip negative 1. Oh, sorry, flip undefined, 0. Apologize. It used to be the other way. Secant is going to flip cosine, so this is going to be undefined. And then we'll get a negative 1 here. And then we'll get the same undefined 1 and undefined that we have across the top. So, now we're going to talk a little bit about signs of these guys. Signs are going to be really important for us. And so this is example number 4. If xy is in quadrant 3, so this is the point xy, it's in quadrant 3. What about x over r? Is that going to be positive or negative? It's going to be negative because your x is negative. X over y, well, your x and y are both negative. If you take the result, if you divide them, it's going to be positive. And r divided by y, remember what that is. That's secant, right? This is secant right here. And doesn't really matter. Our r is always positive. Our y is negative. So this guy is negative. Okay, so again, remember these coordinates here are negative, negative. We don't know what numbers they are, but we don't care. Negative divided by a positive, negative. Two negatives divided positive, positive divided by a negative, negative. Okay, find each of the following. Cosine of cosine of negative 90 degrees. Well, let's take a look at what negative 90 degrees is. That's right here. Cosine corresponds to x. We're off 0 in the x direction. Secant of negative 540. Well, where is negative 540? Let's go find it. So here's negative 360, and then we would go 180 more. It's right here. Now secant is the flip of sine. So the secant of negative 540, I'm trying not to look up to the chart, but it's going to correspond to the secant of negative 180 degrees. Well, what's that going to be? Well, that is going to be 1 over the sine. Sine corresponds to x, and I'm sorry, sine corresponds to, oh, sorry, it's going to be 1, I apologize, I said that wrong. Secant's going to be 1 over cosine, right, of negative 540. Cosine corresponds to x, so this is going to be negative 1 in that direction. So everything you want to be able to picture in your mind. The pictures will help out a lot. I draw a lot when I do trig. So how about 1800 degrees? 1800 degrees is 5 rotations around, I'm sorry, is 5 360 degrees, right? So it's going to be right here on this line. So let me go in a different color. This is where, oh, didn't change my color, sorry. This is where we're at, right there at 1800 degrees. And so they want the tangent of them. Tangent's y, 0 over x, something, but doing the division, we just end up with a 0 in there. So all of these should agree with our pictures as we go up. The secant of 180 degrees, I said, was negative 1. It is. Cosine of 270 is 0. It is. And then the tangent of a 360 degree angle is absolutely 0. So we're doing great. And then they're just going to have us memorize these a little bit better by playing around with some situations. Tangent of 0 degrees is 0. 6 times sine of 90, so 90 is up like this. Sine corresponds to y, so this is going to be a 1, and we're going to get a nice negative 6 out of that. Cosine squared negative 180. We want to make sure you're seeing this right. This is cosine of negative 180 degrees squared plus sine of negative 180 degrees squared. That's the interpretation. So we got to figure out the cosine and sine. So the cosine of negative 180, where is that going to end up? It's going to end up right here as we go backwards 180 degrees. Cosine corresponds to x. Our x would be negative, so this is going to be negative 1 squared. Sine corresponds to y, so that's going to be 0. And we're going to square that, and we're going to end up with a 1 in there. Okay, that you'll see a Pythagorean relationship that sine squared plus cosine squared of any angle is equal to 1. It's pretty cool, and it always works. And it's because of the circular nature of everything, why we had you do circles in Appendix B. So here we have 3 times whatever the sine of negative 90 degrees is squared. Well, where's negative 90 degrees? It is right here. Oops, I meant to switch the colors. It's right there. And so what is that? That's a negative 1 in the y direction. Minus 5 tangent pi. Where is pi? Well, pi is right here, right? This is pi. And tangent is y, which is 0 over x, which is something, but that's going to be 0. And then plus 6 secant squared of negative 3 pi. Oh, sorry, of just 3 pi. So we're going to square something here. So secant is the flip of cosine. 3 pi is right here. Let me go a different color. Here's where 3 pi would end up. So here's 2 pi up to that point, and then another pi. It's going to bring us right here to 3 pi. Now secant is the flip of cosine, and cosine corresponds to x, so this is a negative 1 as well coming through here. And so what do we have? Switch back to blue. We have 3 times 1 plus 6 times 1 for 9. And it's a great way to just try your trig skills out in a larger setting, and it just continues, right? This is negative 3 times sine of 90 is 1. right? Get straight up. Sine corresponds to the y. Cosine of 180 degrees, that's off on the left-hand side. Cosine corresponds to x, so it's going to be a negative 1, and we're going to cube it. And so we just run this and get negative 3 minus 4 for negative 7 as quickly as we can. And notice we're mixing in the radians with the degrees just to keep you on your toes, right? Just to utilize that 3.1 nature. So there's no difference between 90 degrees and pi over 2, so that's going to be a 1 as well. 2 cosine, let me just figure that out. I don't need to write cosine. I'll keep the same patterns that I've been doing before. Of 3 pi over 2. Well, cosine corresponds to x, and if you look at 3 pi over 2, it's down here, right? Here's 3 pi over 2, because this is pi over 2, this is 3 pi over 2. Cosine corresponds to x, we're off none in the x direction, and so we're going to put a big hunkin' 0 in there. Minus tangent of 2 pi. Well, 2 pi ends up right here. And tangent is y, which is 0. And I'll go back here, which is 0 over x, or 0. And so all we end up with here is the number 5. And so decide whether each expression is equal to 0, equal to 1, equal to negative 1, or is undefined. So sine of n pi, sine is never undefined. So as you think about when you're at the pi level, you're on the flat level. And so sine corresponds to y, so this is going to be 0. Tangent of odd number pi's, right? 2n plus 1 puts us at odd number pi's. So that's here and here. So tangent corresponds to y over x. Well, our x is going to be 0 on either one of those two lines, and so we're going to be it's y over x, and so because it's y over x, we are going to be undefined because our x is 0. So let's go up and double check that, right? We could doubt ourselves, but that's why we have these charts to go back to. Let's look at tangent at 90 degrees and 270 degrees, and it absolutely is undefined. How about cosine of even pi's? Right here. So that n times 2 is always going to be an even number of pi's. Even pi's always end up on the positive x-axis. Cosine corresponds to x, so it's going to be 1. And I'm just trying to get you the thought process here. And cosecant n times pi, cosecant of any pi, let's remember that pi is, or cosecant is 1 over sine of n pi. And if we think about sine of n pi, if at all the pi's, actually we did it over here at the very first one, we're flat. And so there's no y height, so that's going to be 0. So this is going to be undefined. So notice that we're relating it back to that number 94 that we started with. We know that that's always going to be 0 on the bottom, so the cosecant is always going to be undefined. So pretty cool in that regard. That's what we have for section 1.3, I believe is what we were just doing. And so we'll make another video that will further explain the concepts. We get comfortable with these quadrantal angles.